welcome back to the SWAYAM NPTEL course on mechanical and electrical systems of mining machines. We are in module 2, that is mechanical systems in HEMM. So, we were continuing with mechanical transmission in shovel. So, last class we discussed about the power transmission that is happening in shovel. We have already discussed the power transmission that has happened in two shafts, that is the crowd and bucket hoist shaft and the boom hoist shaft, and in this class we will be discussing about the power transmission that is happening in the swing and propel shaft, and then we will be going to the undercarriage unit and the power transmission line in the front attachment. Now, coming to the power transmission systems that we discussed in last class, we have covered the bucket hoist, crowd and bucket hoist shaft, and boom hoist shaft also we have already covered. This is pinion. So, today we will be going to swing and propel shaft. So, last class we discussed that if let us say the engine shaft is rotating in anti-clockwise direction. So, since this is a chain sprocket and chain mechanism, so these are two sprockets and there is a chain over it. So, my swing and propel shaft will also rotate in anti-clockwise direction. So, this is the gear which is housed on the swing and propel shaft. Now, this is engaged with the boom hoist shaft, where my boom hoist shaft will rotate in clockwise direction, and my crowd and bucket hoist shaft will rotate in anti-clockwise direction. So, now let us go in details of the swing and propel shaft. So, now when we talk about the swing and propel shaft, so there are some of the errors. Okay. In swing and the propel shaft, what did we assume? That it is rotating in anti-clockwise direction. Now, this is the construction of a swing and propel shaft, which helps in the swinging action of the turntable, and the propel action of the shovel, which gives the power to these crawlers for forward and backward movement. Now, let us try to understand it properly, that when the swinging action takes place, the propel action cannot take place. So, this is the first point that you should note. When the swinging action takes place, the propel action cannot take place, and when the propel action takes place, the swinging action also cannot take place. So, vice versa, two actions cannot happen at the same time. Now, when we see for this on the swing and propel shaft, so the first component is there are two cone clutches. There is a left cone clutch and then there is a right cone clutch, and then there is a left bevel gear and then there is a right bevel gear, which this cone clutches get engaged to this left bevel gear and right bevel gear. Now, first let us say the cone clutch on the left side gets engaged to the bevel gear that is on the left side. So, this cone clutch is rotating in anti-clockwise direction, right. So, it is rotating in anti-clockwise direction. Now, this cone clutch when gets engaged to this bevel gear 1 BG1. So, this also is rotating in, my BG1 is also rotating in anti-clockwise directions. So, this is let us name it as BG2 and this is BG3. So, this is also a part of the bevel gear. So, I hope you remember what is the bevel gear from the toothed gear lecture. Since my BG1 is rotating in anti-clockwise direction, my BG3 will rotate in clockwise direction. So, my swing and propel shaft will also rotate in clockwise direction. So, here let us name it as gear 1. So, my gear 1 is now rotating in clockwise direction, which is now engaged to one gear here, and then it is connected to another gear here. So, let us say this is gear 2 and this is gear 3. So, my gear 1 is rotating in clockwise direction. So, gear 2 will rotate in anti-clockwise direction, gear 3 will rotate in clockwise direction. So, now when my gear 3 is rotating in clockwise direction, so as we can see here, this is a ring gear and this is the point where the shafts move inside the ring gear. So, and this is the swing clutch. So, these are the swing brakes and this is the swing clutch. So, my swing clutch gets engaged with this gear 2. My gear 2 is not keyed to my swing shaft. Okay, so this is the swing shaft. So, this is the swing shaft. So, my swing gear 3 is not keyed to the swing shaft. However, my swing clutch is keyed to the swing shaft. Okay. So, when my gear 3 is rotating in clockwise direction and now swing clutch gets engaged with gear 3. So, when swing clutch gets engaged with gear 3, my swing shaft now rotates in clockwise direction. Now, when my swing shaft rotates in clockwise direction, so it means it completely rotates my ring gear. When it is rotating in clockwise direction, so it would rotate my ring gear in anti-clockwise direction. Ring gear in anti-clockwise direction. So, when my swing shaft is rotating on, so there is one gear here and this is the complete ring gear. So, let us say this is gear 4, my gear 4 is rotating in clockwise direction. So, my ring gear will rotate in anti-clockwise direction. Now, how do I change the direction of the swinging of this shaft? I just cannot change the movement of the or the direction of these gears. So, what do I do now? I completely stop the mechanism, the complete power transmission in this mechanism. So, I detach the left cone clutch and I engage the right cone clutch, engage the right cone clutch. So, when I engage the right cone clutch, so my right cone clutch is now rotating in anti-clockwise direction. My right bevel gear is now also rotating in anti-clockwise direction. So, now I suggest you take some time and think, when my BG2 is rotating in anti-clockwise direction, my BG3 reverse its directions to from clockwise to anti-clockwise direction, right. So, when my BG1 is rotating in anti-clockwise direction, my BG3 was rotating in clockwise direction, but when my BG2 is rotating in anti-clockwise direction, my BG3 is rotating in anti-clockwise direction only. Okay. So, that leads to the anti-clockwise direction of the swing and propel vertical shaft. So, this leads to anti-clockwise direction. So, now my G1 is anti-clockwise direction, G2 is clockwise direction and G3 is anti-clockwise direction. So, due to the anti-clockwise direction of G3, so the swing shaft when the swing clutch gets engaged to the G3, so at that time my swing shaft is also rotating, will also rotate in anti-clockwise direction. So, that leads to my G4 will also rotate in anti-clockwise direction. So, this will lead to the clockwise motion of the ring gear. So, when my left cone clutch is engaged, my swing shaft is rotating in clockwise direction, which is leading to the anti-clockwise movement of the ring gear. Now, when the right cone clutch is attached, so at that time my swing shaft is rotating in anti-clockwise direction, and that leads to the clockwise direct movement of the ring gear. So, it can move left and right with this power transmission mechanism. Now, coming to the propel shaft. So, similar way my left cone clutch, this is shaft, this is brake. So, my left cone clutch gets engaged. So, the left bevel gear, this is BG1, BG2 and BG3. BG1 would rotate in anti-clockwise direction, then BG3 will rotate in clockwise direction. So, the swing and propel vertical shaft would rotate in clockwise direction. So, here we have G1, G2, G3 and finally, this we have named as G4 here. So, let us name it as G5 here. So, this is the ring gear, complete ring gear. So, when we talk about G1 is rotating in clockwise direction, G2 anti-clockwise direction, G3 in clockwise direction and G5 as anti-clockwise direction. So, now when my propel clutch is engaged, so the propel shaft will rotate in anti-clockwise direction. So, here I have BG4 and BG5. So, when my BG4 will also rotate in anti-clockwise direction, my BG5 will rotate in, when my BG4 rotates in anti-clockwise direction, my BG5 will also rotate in anti-clockwise direction. So, when the left jaw clutch gets engaged, jaw clutch left gets engaged. So, this shaft also rotates in, we can tell it as the shaft in main frame, also rotates in anti-clockwise direction. So, when this rotates anti-clockwise, so there is This is one sprocket, this is the other sprocket. This also starts rotating anti-clockwise and it moves to the forward movement of the machine. So, similarly, when we would disengage the left cone clutch and engage the right cone clutch, the complete direction would be reversed and the machine would move backward. So, this is how the complete power transmission looks like in a shovel. I hope you understood quite well the power transmission that is happening in all the three shafts, that is the crowd and bucket hoist shaft, boom hoist shaft and the swing and propel shaft. Now, coming to the undercarriage unit. So, we know that the undercarriage unit is known as the crawler travel unit, which has a main frame, which you can see, this is the main frame, and above it we have the bull gear or the ring gear, which looks somewhat like this, and then there is a control pin or a central pin here, which helps in the swinging motion of the complete turntable. Now, when we talk about this crawler unit, so this main frame extends to the right side and left side, where we get a mounting unit something like this, which we call it as a crawler frame. So, this we call it as a crawler frame. So, on both sides we have crawler frame, and on the top of the crawler frame, so there these are the carrier rollers, you can see these are the carrier rollers. So, here there are multiple rollers which we call as the carrier rollers. At the bottom we have the track rollers. So, these you can see these are the track rollers which completely move throughout the crawler frame. So, these are the track shoes, and these track shoes are connected by this pins on below which there is this sprocket arrangement moves, this the chain moves under tying this track shoes together. So, there is a tension adjustment unit which helps in the tensioning of this the sprockets, which keeps the track shoes always in certain amount of tension without loosening of the track shoes. Now, if we see clearly how does a bull gear looks like, you can see this is how a bull gear looks like, where there is a huge rack top plate onto which there is a ball race, something which looks something like this. This is the ball race which helps in the smooth swiveling of the complete turntable. So, why do we need a ball race? Because that reduces the contact between the two links, that is ball is one link, the race is the other link. So, that gives it as a higher pair, and this reduces the friction. If had it been a surface to surface contact, the friction would be higher and it would lead to high rate of wear and tear. So, due to this ball race, ball and bearing that we see in this complete ring gear or the bull gear, that helps in the smooth swiveling of the turntable. Now, there is a central post you can see onto which the superstructure is mounted. So, this mechanism helps in the smooth swiveling of the complete machine. So, I have discussed this in the last slide, where there is a main frame of the crawler unit, and then this is the crawler frame, these are the track rollers, these are the sprockets, this is the tensioning arrangement that helps in tensioning of the sprockets to keep the track shoes always in tension. for their smooth and efficient operation. And there is below this track shoes, there is this track chains which you can see, these are the track chains. Okay. Now coming to the front attachment. So in the front attachment, as discussed, the front attachment has a boom, has a dipper stick and has a bucket. So when we talk about this bucket which is rigidly attached to the front end of the dipper stick, while the dipper stick and the bucket combination is held by a rope, which you can see, this is the hoist line. This is one hoist line. The first hoist line is the boom hoist line, which goes here. So this is the hoist line, this is a first hoist line, and this is the boom hoist line 2. So this is the hoist line for the bucket, and then there are also there are shipper drums onto which these pinions are housed onto, and this is how the complete arrangement looks like, where you can also see the sheaves onto which your bucket is hoisted. So this is the crowding sprocket and this is the sheave onto which the bucket is hoisted for the crowding action, and this is the boom hoist line which you can see here. This is the boom drum, so which would be winding the rope that is coming from the boom. Now that's it. We complete the complete section of the shovel. You can follow these books for references. Next class we will have certain numericals on shovel, determining its capacity and efficiency and the cost that is incurred while operating a shovel. Thank you for this class. See you in next class.